Welcome back to my channel Zoology at 180. Today we'll discuss about one of the important topics for the NEET examination, that is generation and conduction of nerve impulse. This is the part 1, the resting membrane potential. Dear friends, try to understand the structure of the axon. The nerve impulse which is carried throughout the axon is a charge, a potential, called as the resting membrane potential. To maintain this charge differences, we require two ions, the potassium K+ and the sodium Na+. Now, how are these ions exchanged? As you can see, the axolemma is separating the axoplasm with the ECF. The axolemma allows only the positively charged ions and does not allow the negatively charged ions. That is, the negatively charged proteins present in the axoplasm are not allowed to move, whereas the K+ and the Na+ easily move in and out. The axolemma is more permeable to the K+ ions and comparatively almost impermeable to Na+. We're not saying impermeable, it is almost impermeable. The concentration of K+ is more inside the axoplasm, whereas the concentration of sodium is more in the ECF. So, the potassium has a tendency to move out and the sodium has a tendency to move in. As the permeability is more for potassium, you can see there is more movement outside compared to the sodium inside. But to generate the charge difference, we need to pump them back into their original places using the ATPase enzyme. Now, this is called as sodium-potassium pumps. If you remember, potassium movement was more and sodium movement was less. But the pumping occur in a different manner. How they are pumped. The potassium is pumped in and sodium has to be pumped out. Now, for 2 potassium pumped in, 3 sodium are pumped out. 2 potassium pumped in, 3 sodium pumped out. Due to this, as more Na+ is moving outside has a more positively charged potential. This attracts a negatively charged proteins on the inner side of the membrane. This will lead to a difference in the charges across the membrane. This charge difference is called as resting membrane potential, which is nearly minus 70 millivolts. Such a membrane is called as polarized membrane. Any disturbance in the resting membrane potential is called as the action potential. We'll continue with the action potential in our part 2.